So, hi folks, and welcome to the next exciting session of the ION conference. My name is Shumon Huque, and I'm from the University of Pennsylvania. And I'll be moderating today's panel, which has kind of a bold title, Advancing the Network, Where We've Been and Where We're Headed. But we've assembled an illustrious panel for you today. I'm going to do very quick one-liner introductions for each of the panelists. We're going to allow them to do a short presentation where they should feel free to do longer introductions. So to my left, we have Ron Broersma, who is the Chief Engineer of DREN, the Defense Research and Education Network, and a long-time deployer and advocate of IPv6. Next, we have Paul Ebersman from Infoblox.
Yes.
And I understand you do a lot of IPv6 stuff there too, right?
Yeah.
Maybe
yes.
among other things. Good. John Spence from DNSSEC. And last but not least, we have Paul Mockapetris, who probably needs no introduction here. And in case you didn't know, he is the inventor of the DNS. Okay? So the format of this panel is I'm going to do a few brief introductory remarks, and then I'm going to turn it over to each of the panelists, who will do a 5 to 10 minute presentation each. And the remainder of the time will be devoted to audience Q&A with the audience or panel discussion. I have a set of topics in mind that I would like to ask the panel, but I'm going to hold on to them because what I intend to do first is solicit the audience. So fair warning, if you haven't done so already, please start thinking up interesting questions and topics that you might want to pose to the panel, okay? All right. So let's talk a little bit about World IPv6 launch. Everyone here familiar with this event? Did anyone not hear about this event? Okay, no hands went up, so I think we're talking to the right crowd, right? So this was an event that happened on 6th of June of this year, organized by the Internet Society, these folks who have organized today's event. And organizations around the internet were challenged by this date to enable IPv6 in production on their application services and network infrastructure. And many organizations indeed did respond positively to that challenge. So they include some of the major content providers like Google, Facebook, Netflix, Yahoo, Microsoft, Bing. ISPs and content delivery networks were involved. And also an assorted group of universities, corporations, government agencies, and other entities. So IPv6 is still in a pretty fledgling state of deployment. However, earlier this month, I think, arguably an important milestone was achieved. According to Google's own measurements, IPv6 traffic finally tipped over the staggering 1% mark, right? Yay for IPv6. However, the internet is a gigantic place, right? So 1% of the internet is a fair amount of traffic. And as you can see, the graph is going in the right direction. Not only is it going in the right direction, but it seems to be on an upward and accelerating trajectory, at least recently. That's a good sign. And in certain sectors and certain areas, the picture is actually quite a bit more positive. So if you look at people who do statistics of IPv6 deployment in certain geographic areas and certain sectors, it's way more than 1%. I'll give you an example. The World IPv6 launch's own measurements, there's a URL to their site at the bottom of the slide. Some universities generate 60% of their traffic to IPv6 enabled sites switch over to IPv6. This is because these sites are very popular and very high traffic generating, like Google and Facebook and YouTube and so on and so forth. So it's a reasonably good picture. And in case it wasn't abundantly clear, we do have a crisis, an impending crisis on our hands because we are running out of IPv4 addresses. I'm not going to dwell too much on this slide, but these are some statistics and prognostications from Jeff Houston, who probably a lot of you know here. He's the chief scientist for APNIC. He does a lot of measurements and data collection. And quickly here, you'll see that the IANA, the top-level allocator of IPv4 address blocks, they already depleted their entire allocation. That isn't a prognostication, by the way. That's an event that actually happened. happened in March of 2011. So all the rest of the address blocks are in the hands of the 5 regional internet registries, and if you look at their projected exhaustion dates, you'll see some of them have already depleted their allocations, and the others are getting pretty close. So what's going on? Let's switch gears a little bit to DNSSEC. The DNSSEC root was signed in July of 2010. And the level beneath the root, the top-level domains, there's a pretty encouraging picture there as well. About 104 of 316, that's 1/3 of them, have already deployed DNSSEC. And that includes the generic TLDs as well as many of the CCTLDs and also some of the IDNs as well. You can see detailed statistics at this URL. The reverse DNS trees, at least the top levels of those, are also signed. So most of the remaining work has to happen below that, and there the picture is a little bit more depressing, but there are pockets of DNSSEC deployment in certain communities. I'll skip over the state of registrars. We heard about it all at the earlier panel. And lastly, I'll talk a little bit about SecSpider, which is a DNSSEC zone monitoring project run out of UCLA. And by their statistics, they measure about 205,000 signed zones as of mid-2012. Okay? And with that, I am going to turn it over to Ron. Let's see. That's not you. Yep, sure.
Okay. Thank you. So I'm Ron Broersma, and I have the advantage of wearing a number of different hats in the federal government, so I get to see this IPv6 issue from another number of fronts. I am the engineer for one of the large ISPs in the Department of Defense. That's DREN, and so I see it from an ISP perspective. Also run some enterprise networks as the security manager for those networks, and so deal with a lot of security-related issues in those environments. But then I'm also on the Federal IPv6 Task Force, which is working hard to try to deploy IPv6 to all the federal agencies, which is now mandated with specific deadlines. And so that's been useful just to see it from all the various aspects. The first slide I want to put up is just some of the statistics from the U.S. government IPv6 deployment. And on the left are the 22 major agencies, like the cabinet level agencies and others within the federal government, and how they're doing. And you can see that, I mean, the ideal would be as they were green across the board, but there's some green, some yellow, and a lot of red still. So not everyone, well, none of the federal agencies met the 2012 deadline, which was all public-facing services had to be IPv6 enabled by September of 2012. But you can see that on the chart in the upper right, look at the blue line, those are websites. And as we approach the September 2012 deadline, there is certainly a ramp up. So deadlines help get people attention. But then once you pass the deadline, there's maybe lack of incentive to keep going. And so it sort of flatlines a little bit. And so the question is, what can we do to make that continue to accelerate? The chart at the bottom right shows how many services became v6 enabled, and it was about 40%. And so one might ask, well, was this a success or a failure? Because if you didn't reach 100%, it looks like a failure. On the other hand, I would argue with that and say that to actually get to green for any one of these services or domains was an incredible amount of work, because it meant you had to do all the planning, all the training, all the procurement, all the re-engineering, getting your ISPs on board, getting your security infrastructure upgraded, finding all the problems in your network, like maybe load balancers that didn't support IPv6 or ISPs that didn't fully support it, and many challenges. And doing this for large federal bureaucracies was incredibly difficult. But because of all that, with all of that, 40% of the services succeeded in getting IPv6 enabled. So from that perspective, I think it was a huge success, because now, if you think about it, before a lot of these recent efforts, we heard from a lot of vendors, it's like nobody's asking for IPv6, why should we hurry up and put priority on implementing all those features? And that has really changed, because now when you have the weight of the entire federal government of the U.S., many agencies, many sub-agencies. I mean, some of these agencies are the size of small European countries. I mean, these are really large organizations, some with millions of people. So you have that kind of demand signal on the vendors. Please deliver IPv6 services. It's really been a game changer. But also a lot of other governments have looked at the successes and say, we need to do that. We need to have similar mandates. And so we've learned a lot in the process, and I think it has been a huge success. And we have now new deadlines. I mean, we haven't stopped. There's now the 2014 deadline, which is where all the internal systems need to be IPv6 enabled, which is going to be an even greater challenge since that's what's being worked currently. So it raises some questions about what are we going to do to keep the pressure on in the federal government. And one of the incentives is the CIO of the United States has decided that you will not be able to get your domain renewed if you are not IPv6 enabled and probably not DNSSEC enabled. That's a real incentive. So one of the lessons learned is you have to have leadership involvement, and it means the CIO at the top has to understand the importance of IPv6, DNSSEC, and push it through the organization and hold people accountable to make it happen. That's the way you have success. I think, and I've been saying this for a long time, but I think it was validated if you read the press in just the last week, what happened in the UK, where basically the group that was pushing IPv6 finally disbanded and gave up because their government was not supportive. You need that support from the top or you will fail. So just want to reiterate that. So we're encouraging other governments, other organizations to do similar things. If you control domains or whatever, when people come to you, they want something from you, you should ask for something in return, whether it's money or whatever, but it should also ask, I want to see that you're IPv6 enabled, I want to see that you're DNSSEC enabled. And so I encourage that for many of the other domain operators. Some of the top deployment challenges, really quickly, lack of feature parity. That's been a problem for the last decade, and it continues. Vendors not eating their own dog food. I've been beating that drum for a decade. You know, they sell us the stuff, but they're not using it in their own networks. We found that over and over again, so we're finding all their bugs, and we'd rather them find the bugs before they give it to us. Rogue router advertisements, continuing problem, mostly because of Windows ICS turned on. There are some workarounds, at least until we get RA Guard. Privacy addresses in the enterprise are a killer because we want stable deterministic addresses, and these privacy addresses, which are now default in all the major operating systems, are hurting us, and there is not a solution to that. We have not yet found a solution for the enterprise. Lack of DHCP v6 client support in a lot of the older OSs is still a problem, even some newer OSs like Androids, and so you will have to have Slack available for assigning addresses and other things. Operational complexity with dual stack. When you've lived on dual stack for many years, like we have in some of our enterprises, it gets old and you want to get rid of IPv4. So we absolutely are working on trying to turn off IPv4 wherever we can. And I've got a couple examples of that. And one of the areas is network management. We thought, hey, our network management subnets do not need to talk to the internet. In fact, we don't want them to talk to the internet because these are security zones. So if they're isolated, why can't we do IPv6 only? And so we've been trying hard to do that, and it's been a lot harder than we thought. And I've got a slide on that in a second. So some of the keys I mentioned: CIO involvement. It's got to permeate the organization. You've got to have a culture. You've got to have ISPs that support you. And that's enough on that. It's not like you're going to immediately be able to get to some new website you couldn't be able to get to before. Really, the benefits are going to be long-term once the whole world reaches critical mass on v6. But if you really want to know some short-term advantages, on the addressing front, it's a whole new ballgame, and operational complexity goes way down because no more bit math, no more growing subnets, no more trying to figure out how much address space do you need or whatever. I mean, it's basically, you know, sites get a /48 and subnets got a /64, end of discussion. And the problem we see in the federal government has been there's whole organizations that have been stood up to do nothing but address allocation, and we're putting them out of business, and they don't like it. And so they're really fighting this. They want you to have to justify that you need this much address space, and then they'll give you just the amount you need and then say come back for more when you need it. And we're saying no, a site gets a /48 and their hair turns on fire because you're being wasteful, you're going to run us out of address space, just like in IPv4. And so don't listen to that guy. And hear a lot of that. Also, link local on every interface. Think about it. With v4, it was only there if it couldn't get a v4 address some other way. It would assign the 169.254 or whatever it was. Now, ubiquitous link local that is usable. Think about it. You can use that for a lot of stuff. Very cool. Multicast is way simpler because of embedded RP, no MSDP. If you've ever run multi-domain PIM, multicast v4, it's very hairy to keep it running reliably. And in v6, it's way simpler. It's beautiful. Same with mobile IPv6, much cleaner, much simpler, all the home agent, foreign agent stuff. Jan has a great demo that we've done a few times. We got the video. And once you see the demo, it's like you get it. It's like, now I understand. This is so cool. I got to have mobile IPv6. Just need some implementations now. So there are great benefits out there that you're going to love. Also, quick word on management only. This was a project we started like 5 or 6 years ago. Let's do IPv6 only on our management LAN. We'll turn off v4 and see how this goes. All the products, some features worked, some different. Even though they claimed full v6 compliance, and they went through all these testing labs and JITIC and interoperability lab and so forth, when it comes to put it into production, you find all the missing pieces. So here, ooh, that looks weird. Well, it's good enough. So you can see some of the major, in our environment, we got Cisco, Brocade, Juniper, Alcatel, A10s, Arubas, and so forth. And we started this chart on all the things you need to be able to manage those devices. You need a SSH into it. It needs to do DNS, syslog, SNMP, all that stuff. When we started this, that was a sea of red. Maybe you could SSH into it over v6. Maybe might be able to do syslog and a few other things. And gradually, this has really shifted to where, at least in the upper left, it's more and more and more green as we poked on the vendors. Our goal is, let's try to discover this in our research networks now so that when you all get around to wanting to try this, it will just work. And so you won't know how broken it's been, but if we can get it all fixed before you try it, you'll be happy, and we're just trying to save you from that. The biggest one we've been working on lately is flow export over v6. I don't know why so many didn't implement that, but most are scheduled to get it done within the next few months or 6 months or so, and then we'll continue to work the others. I was telling Shumon last night about Aruba. We've spent the last month or two trying to see if we could do Aruba wireless over IPv6 only, and found that it doesn't work very good, and there's a whole lot of broken parts. But we found how much you could do, so that was good. That's it. You can send me email if you want me more information.
Okay, thanks very much, Ron. Should I just pass the laptop down?
Look, I kept it to 10 minutes exactly.
Excellent, okay, all right. An on-time finish for Ron. Okay, does he get a prize for that?
No pressure.
All right. Okay, Paul, you're up.
He's got a mic. So it disappeared, so...
Okay, here. Yeah. We get loaded last round. Okay. Is this mic on? Yeah, okay. So I'm Paul Ebersman. I work with Infoblox, and I actually get to do IPv6 full-time. I'm one of the evangelists that we have working there, and most of what I do is going out and meeting with people and finding out where they are, trying to make people aware of where they can get resources for education, share the collective experiences of what people have tried already, cleansed of who I've talked to, but keeping in the operational issues. I also go to the IETF and I follow the several working groups, now mushrooming number of working groups that are dealing with IPv6. And what I've got here actually is just sort of some highlights of some things that, particularly from the sysadmin level, or when you get beyond core routing and switching gear, the issues that people are hitting and a lot of the holes that we're getting there. And before I dive in, I'll also hit on a couple of points that Ron has made that I tend to tell everybody. One of them definitely is top-down is the only way that works. If upper management or the folks at the high-level authority with the check-signing abilities are not convinced, ground-level movements and grassroots movements do not work, they die. The other thing that I tell everybody is we've had this chicken and egg thing where vendors will say we gee, we don't have v6 products because people don't want them. That's not the features they ask us for. And I go and talk to the companies and they say, well, we're not rolling out v6 because nothing's ready yet. And so as strange as it may sound coming from a vendor, I have a very simple solution, which is start beating on your vendors now and saying we need it now, and start getting them rolling it out now and testing it now.
What about APAC and EMEA? If they don't have access.
Could you use the mic?
Repeat the question.
Yeah, the question was APAC and EMEA, they are running out. They have technically run out there in starvation mode. And the quick answer is that they are more aware of it than in the US. But many of the customers that we have at Infoblox are large corporations and governments who, even in Europe and Asia, have stockpiled large chunks of address space and don't yet have a crisis. So it is a very difficult argument to make. But even if you can't get management to sign off that you need to buy v6 gear, if you can get all of your vendors to the point of, I'm not buying anything new that is in-house now that is not v6 capable, and when I say v6 capable, I need you to prove it, that's a good start. So let me get through some of these points here, and then we can, we'll get through the questions. So one of the biggest areas and one of the biggest changes with v6 is stateless auto configuration in DHCP v6. It's definitely a protocol level ground up complete redesign from v4. So one of the biggest changes and one of the biggest issues is MAC addresses are no longer used as the identifying feature of a machine. And the IETF's justification for that, which are true, is even though in theory it's supposed to be unique, we all know that it is possible to get shipments of cheap gear that are not unique. It can be altered in software, so even if it's shipped unique, it doesn't mean that it is when it hits your network. And if you have a box that has multiple network interfaces, they all tend to identify with the same MAC address, and you can't do multiple DHCPs. And these days, where pretty much every laptop has a wireless, and probably even a cellular dongle all on the same box, that's becoming an issue. What the IETF failed to look at was the fact that, yes, that is indeed a list of valid flaws. But the reality is that 99.99% of the entire internet probably gets on by getting DHCP address from someone who identifies them by their MAC address, and the internet has not ceased to function. So while it is not perfect, it's obviously functional. But being them, they decided to try and engineer things to fix these, and what they came up with was the DUID, the DHCP Unique Identifier. There are some things that they did do correctly and that are improvements. One of them is that there is one DUID per system. Whether it is a DHCP client or a server, you only have one DUID. What they then do is they have an IA or identity association per network interface on that host. And that pairing of the DUID and the IA is guaranteed to be unique, which means you can DHCP for every single interface, and they are all different to the server and to the client. Those are the good things. Some issues that they didn't really think about, though. One of them was that an awful lot of people do walled gardens, they do filtering, they do fixed or reserved addresses, they do all sorts of things that depend on the MAC address of the client. And DUID is not yet a viable substitute. And with the current protocols, once you go through a relay, you don't get the MAC address and have no idea what the MAC address of that host is. So if you're trying to correlate that it's the same user and or same machine for v4 and v6, which is not a terribly unique or insane requirement, you've pretty much made that impossible. One of the other things they didn't really think about was the DUID is stored in persistent storage, registry, or in a disk file or lease file, which means that if you are ghosting machines and reproducing them to bulk, you have now recreated the problem. You can have multiple clients that suddenly have the same DUID. And it's changed in software because it can be written on disk. So of the three original problems they had, they've solved one and left two unchanged. There's also the whole route advertisement versus DHCP, i.e. Slack versus DHCP. And there have been multiple religious wars from both sides. There are the everything should be in RAs and everyone should do Slack, and DHCP was a horrible idea and we should get rid of it. Unfortunately, those guys took about 5-6 years to figure out that you didn't get a recursive DNS server if you didn't have DHCP. So they did finally get it added to the RAs. Unfortunately, RFC 6106 support is not universal. And as we all know, client and desktop OS upgrades are a very long tail. Raise your hand if you don't have at least some XP-based and 32-bit and IE6 or earlier boxes. Yeah. And of those that raise your hand, how many of you are network providers or small companies that do hardware refreshes very regularly? Yeah. So trying to get OSs upgraded to deal with that, it's really lovely, but the reality is if you want to do an RA solution, if you don't control your entire client population that's coming in there to do Slack, it still won't work because they won't have DNS. And pretty much what you get are default routes, DNS, assuming you can do that, and prefixes. You can't do complex configuration, so all of the god-awful stuff that the vendors have foisted on us in terms of IP phones, printers, and all sorts of other horrid stuff we have floating around in the corners of our network, which do use DHCP and vendor options, don't function in an RA environment. Okay, so we had the other side that said, I want DHCP v6 and I want it to look and smell like v4. Well, the first thing that you suddenly discover is that there is no default route. Because you're supposed to get that via the RA. And practically speaking, the working groups in the IETF have basically said that getting a default route into DHCP is going to be nigh into impossible. They think it's just wrong, and for some reason, that's the one that they're actually digging in their heels on. You can do a DHCP server per link local, but it's very expensive. Most people don't. So the one disadvantage is if you have a highly distributed environment, Slack does allow you to be pretty autonomous. DHCP requires relays and other things that are harder to keep running. The other thing is if you want to do a DHCP only, of course, the purest reading of the RFCs says you must get a route advertisement message which has the M and O bits set on to say get managed address and get other configuration via DHCP. You're not supposed to start your DHCP discover process without getting an RA. So what it meant was both sides with the we want our side to win have basically guaranteed that you must be running both at all times. There are some other unresolved issues, and I'll just sort of touch on these as things for you to either read about or ask more questions about in the session. Prefix delegation is a really cool idea. This is the idea that rather than just getting an address, you can actually ask for an entire prefix, and that you can then carve out pieces of that prefix to give to subordinates below you. The most common example you hear is the home environment. I have a router or CPE from my provider, and I have a smart kitchen with a refrigerator that does stuff, and I have a wireless network, and I have my audio-video equipment, and I have my office, and my kids are on a different thing so that I can make sure that they're doing their homework when they're supposed to, and I want all of these networks to function in my house. Well, with v4, of course, it's kind of hard to do that because you have to hand configure it, and there's somewhat limited address space. With prefix delegation, you can, via DHCP, give an entire subnet and have a hierarchical network set up on the fly via DHCP. The downside right now is that implementations are rather raw. There are some CPs working on it. There are some providers that are starting to offer prefix delegation as a service. But the Home Networking Group and Softwire and a few other people who are playing with bits and pieces of this in the IETF are very early on in the process. It would definitely behoove folks who think that is an interesting idea to feed operational requirements and use studies to the IETF so they do not operate in a vacuum as per usual. There are other things that we are discovering in operational, and I'm sure Ron's hit some of these too. As he mentioned, even if you go through with the UNH Interoperability Lab and you get USGV6 certification, and University of New Hampshire says it's an interoperability lab, which is sort of true. It's actually a protocol conformance lab that does minimal interoperability testing. Raise your hand if you do understand the distinction between protocol conformance and interoperability. Yes, protocol conformance says I'm following all of the rules, just like your 5-year-old or your lawyer. Interoperability means that you are actually getting what you want to get done, and all of the boxes on your network play nicely and get useful work done. Very different requirements. There is no good interoperability test. Sadly, there's not even good protocol conformance, but at least that's easier to test. We are discovering other operational holes as we are going along. One of them, which there are some drafts being proposed, but is certainly early on, is, okay, so I'm a multiple interface host, and I'm dual stacked. Well, I do my one DHCP v4, and I've used my MAC address, so I've shot my load, and I'm done with that. I now get recursive DNS servers that I put into my etc resolve.conf. I get a default route for v4. I get some other configuration information, and I go on. Next, I start to DHCP v6 because my RA told me to. Okay, I have a wired and a wireless interface. On my wired interface, I get an address, I get recursive DNS servers, and I get some other stuff, and from my RA, I got a default route. Okay, I have an etc resolve conf already for my DHCP v4. What do I do? Well, I go wireless, and I get yet another set of servers. So I now have 3 possible sets of instructions. Do I do last one in wins? Do I combine them all? If I combine them all, how do I sort them? And the OS vendors, who are the ones that we need to figure this out, basically Apple, Microsoft, and the Linux variants for the most part, go back and they say, well, what does the IATF say? And the IATF says, well, that's an operational issue. And there is no answer. So that's one of the issues. Multiple default routes in theory are part of the standards, but again, OS vendors do not have a consistent set of implementations. And the last one, how do I pick the source address when I have multiple v6 addresses? RFC 6724. Currently, there is no well-accepted implementation across all vendors. And again, we get back to the long tail of operating with your clients and getting them upgraded. So some of the things I'm seeing.
Okay, thank you, Paul. Richard, are you going to
Yes.
do the laptop? Great, thank you. So next up, we have John Spence.
Thank you very much. Okay, my name is John Spence. I work for NIFO6. We do IPv6 consulting and training. And I've got kind of, I think, maybe a higher level kind of look at just some general v6 and kind of implementation considerations, I think maybe from a little bit higher level. So in the work that we've done, we've certainly found that v6 implementation is hardly rocket science. I think it's more like an endurance test than a technical challenge, right? Because v6 touches so many things, so many organizations, and there's such an effort to do it from end to end. I think Ron talked about just setting up web servers that are v6 capable on the internet side requires you to go through a long list of things to finish just to do that kind of first step. Things downstream from that kind of follow a little more quickly after you've done all that work. And v6 is kind of like that. It's not that anything in particular is new and extremely difficult to do. It's just that there's a lot of pieces. So lots of these projects can take 2 or 3 years, depending on how much you have to build support in the organization, including from the top down, like everybody here on the panel has said. If you have to do some work with your capital budgets, because you're going to have equipment that needs to be replaced, so you have to get into the budget cycles, that can take a year by itself. So really, you need to expect it to take a while. You need to expect it to be a very big project. And you got to start early. And now in 2012, it's hard to start early. About the best you can do now is you can kind of start now, right? And not be further behind. And in terms of how early you start, it depends a lot on what kind of company you are and what your needs are. Nobody anymore for v6 is on the bleeding edge, right? So now you either have a little time to think about it, maybe if you're an enterprise and you're not very multinational and you're not pushing the envelope much, but everybody's getting close. And it's better to do a v6 deployment when you can take lots of time up front to plan and when you're not under duress. When you're under duress, you don't do it as well, and it costs you more. So there's really no excuse not to start, no matter how small you start. This is just a little screenshot that shows, I think there's 373 RFCs that mention V6, 132 drafts. So in terms of the standardization prospects for V6, lots of standardization work has been completed, a few revisions have been done. So big picture, anything you want to do, anything that needs to be done, most of the standards are well established and well settled out, as are the products. So there's certainly feature gaps in the products. Mostly it's pretty good and it's getting better. By the way, that second one, I think, note ready is a difficult term to pin down. You'll definitely consider V6 ready to be something different than every vendor that you talk to. So when you say, are you V6 ready, and they say yes, they may well mean we are on the forwarding plane. But they won't say that. They'll say, yeah, we're V6 ready. And it's only later that you'll find out maybe some things are done in software that you wish were done in hardware. Or maybe management's not ready yet, that's on the roadmap. So you'll have functional gaps, you'll have performance gaps, you'll have a great variety of what they consider to be the features that make them V6 ready. And what's important to you are the features that you need. So if there's a vendor that's got, say, 100 features, and they don't have the ones you need, that's not as good as a vendor that's got 75 features where they're all the ones you need. So you have to drill down and be specific about what you need and what they have on the roadmap, and how confident you are that the stuff that's on the roadmap is going to dovetail with your 3-year deployment schedule or your 2-year deployment schedule or whatever that is. So this is just a little shot about V6 deployment status. So I've got up there that it's mixed. So I look at this, now it's up there, I look at this, I see a lot of red, and it'd be easy to say, well, V6 deployment's not very advanced. I started working on V6 in 1998. So for me, this is looking really sharp, right? It's taken a long time to get here, but the momentum is definitely moving, right? So there's no discussion about whether V6 is a real thing. There's no discussion about whether we have to do it. It's all about how soon. The next couple of slides are just kind of about the major elements of a V6 deployment. And what you'll find, I think, when you do your deployment is that everything's very iterative. So it's hard to make a good plan until you've done some experimenting and done some learning. It's hard to know what to experiment with until you've done some planning. So by nature, this thing kind of gets to be an iterative process. So I think the point of this slide mostly is just to talk about how V6 is really fundamental to a lot of changes that are kind of going on in organizations today. So it kind of underpins everything. V6 by itself is not particularly interesting. It's just very necessary, and everything builds on top of it. So in this slide, V6 provides the scalability and the growth and the capability for the next 20, 30, 40 years for IP networking. The cloud layer is kind of about outsourcing and delivery strategy and being nimble with delivery. And at the top is more about application enablement and the kinds of tools that you can write, tools you can use to develop applications and deliver services, as we all kind of try to become more agile and more quick to market and faster to adopt our services to what the customers want to buy. V6 underpins that stuff, but I mean a couple layers down. So it's kind of like DNSSEC, I guess, in one of the comments was that it's not by itself sufficient to do that much, but it's fundamental to allow lots of great services to be built on top of it. And I think V6 is really the same thing. I'd also encourage you when you're working on your V6 deployments to not think about how this is going to affect your company this year and next year and the year after, but think of it as a strategic initiative that's going to let you kind of do a once-in-a-generation re-engineering of your network underpinnings to support the future for service delivery for the next 10, 15 years. So as I said before, I think the most important profile for what you need for V6, the most important profile for what makes a V6 product V6 ready is yours. So there are a number of profiles that are available. I got a couple of them up here on the board. RIPE has a profile. The V6 ready guys have a profile. Those are great places to start. What you need to do with your deployment is figure out what's important to you, what are the features you're going to use in your network, and then drill on those specifically with your vendors and your enablement strategy. And I think on this slide, I think the most interesting thing is this last one, to innovate. I mean, we really do have this once-in-a-generation opportunity to kind of change how the network works with the v6. So we're going to eliminate NAT. We're going to have the capability to have end-to-end routability, regardless of how you decide that you want to enforce your security posture, to place limits on kind of the unfettered peer-to-peer kind of utopia that maybe v6 started with in 2002 or 2003, when there was a lot of talk about peer-to-peer and end-to-end and restoring that paradigm. But v6 really should be an enabling platform for innovation. And if we just take v6 and kind of replace v4 with it, where we've got plenty of addresses, I think we've left a lot on the table, kind of as network service delivery designers. And I think this is my last slide. We wrote a little tool at NEFO 6 that we're kind of having beta testing. It's called v6 Sonar. What it lets you do is lets you check and see the v4 and the v6 latency speeds and kind of relative performance for various websites. So you can go to this tool and put in some website. You find out if it's got a quad A record or not. If it's dual stack, it does some quick metrics to see how the performance is on v4 and v6, and you can kind of see for different sites kind of how good the parity is in terms of real public internet performance between v4 and v6. So it's kind of an interesting tool to kind of look at v6 performance stuff today. It's free, it's worth a try. We're seeking input on whether it's a useful tool, so I'd encourage you to take a look at that. That's
Okay.
all I got.
Great, thanks very much, John. This was great. So while the laptop is migrating to the end of the table, we are running a little bit over, but I think that's because the previous panel ran over and encroached on our time. So
Shift the blame.
I don't know if, so I don't know if we'll be permitted to run over our time a little bit too, but.
Absolutely, you're doing fine. The time that I have there is per speaker, so
Okay.
you're not running over.
Okay, great,
You're good.
excellent.
You're good.
So, but just for planning purposes, could you raise your hand if you think you have a question or a discussion topic you'd like to pose to the panel? Okay, so I see 3 or 4 plans. Great. Hands go up. Great, thanks. Last but not least, we have Paul M.
Hi, I'm Paul Mockapetris. I deserve the blame for a lot of things, one of which is DNS. I built the sort of basement and first floor of the DNS, and since then people have added about 25 more stories onto that building. I'm going to talk a little bit about it. I tend to think of IPv6 and DNSSEC both a little bit like global warming. Global warming is something that's developing kind of slowly, and that's why it's hard for people to, particularly if they're Republican, to kind of grasp the fact that it's dangerous. But on fairness to the Republicans, they also believe that people should have jobs and eat and have heat in their homes. The thing with both DNSSEC and IPv6 is that they're both inevitable. It's just a question of how long it's going to take. When I was IETF chair, I was there, and the IPNG working group created IPv6 and won a beauty contest. And they said, Paul, we really want you to support this renaming to IPv6. And I said, is that because it's not going to be ready till 2006? And they were horrified with the idea that it would take until 2006 for this IP next generation to just take over the world. But it had 0 packets, 0% activity on the net then, and we're starting to see it. And if we do, in fact, get exponential growth in both of these things, because people see it and like it and adopt it, then these things will develop very fast. I'm going to talk more about DNS and advancing the network, where we've been, and where we're headed. And one of the things is that people have more and more names. I mean, I have these domain names for my different mailboxes because I'm both a commercial provider of DNS and DHCP software. That's me at Nominum. And then I have my own identity myself, which is a21.com, because I have a house on 21A Street. And I knew that nobody would ever want the domain a21.com, right? Ha! Right? There's some airline in Texas that wants it because they're Airline 21. There's Ataye 21 in Palo Alto that desperately wants it. and so forth and so on. I thought A1 the steak sauce would be the only thing that was wanted. And I'm also a visiting scholar at my university in Paris. And I think the thing is over the years, the email addresses and the domain names and the identifiers that I want have grown, and I think that's going to be a driver for a lot of what we see. Where we've been, in the early days, people say, well, what was the DNS? It was created to map host names to addresses, and that was its first job, right? Absolutely wrong. The first job that the DNS had was to distribute the database so that everybody could own their own domain. And you might say, well, no, but that, it really was the host address first. Nope, sorry. A DNS server has to go look at those NS records first to find out what name server to ask before it can actually do anything to find the host addresses. So, the distribution was the important thing in the early days. And as far as I'm concerned, this business is about still distributing parts of the namespace to organizations as opposed to individual users or perhaps devices is wrong, and it's something we're going to fix. Over time, what we've been doing lately is making it scale. That's the big thing about making it scale, and seeing all the billions of domains and billions of dollars going into I'm sorry, that's the future. Watching it scale in many dimensions is where we are. But what's next? I think today what we ought to do is we ought to be thinking about what are the new paradigms for security, content distribution, machine-to-machine, et cetera, kind of activities, and how can we enable them on top of these new technologies that we're talking about building. The original design of DNS had all of these fields that some people say were just wasteful. What's that stupid class field for? We just wasted that. I mean, how many bits have we wasted over the years in transmission? But, we were trying to design things to be open-ended. So I think the question that we're really going to have to, the way we're going to decide 10 years from now about whether we were right today, is whether or not IPv6, DNSSEC, or any of these new technologies have sort of useful DNA. Do they contribute to the gene pool that's going to, make them a Darwinian success, whether or not they're particularly elegant? Some shifts. There's an awful lot of more IP addresses out there. We have these different people talk about the exhaustion of the pool. One of the wonderful things that happens to people in the DNS business is that either V6 happens quickly and we have a lot more addresses to manage, or V4 addresses need to be managed a lot more carefully and people pay us to do that. It's great. We would prefer to have the more forward-looking getting paid for the V6 stuff. But to some extent, we'll take what comes. And V6 has a lot more, and we hope it provides the new paradigms. But one of the other things that happened is several years ago, these people from Microsoft did this wonderful operating system called Vista. And I was writing about how Vista was going to handle IPv6. And I said, well, they could do the wrong thing. And when they're look up both V4 and V6, and it would double the number of queries. And I had all of these Microsoft hit squads after me. You're saying we're going to be stupid and we're going to double the number of queries. Okay, so we fast forward to happy eyeballs. Okay. Does everybody here know what happy eyeballs is all about? Yeah, it's basically this idea that the thing that matters is the user experience. And so if we have two choices, we pursue both of them in parallel. Damn the network. It's a virtue now to double the number of queries, right? If only Microsoft had been able to see that in advance. But instead, they were just, they make fun of me all the time about that. And I think that's one of the things that's changing here is that we're not playing by the same rules. Today's rules, particularly in the consumer space, are a lot more about happy eyeballs and being able to do something that's really cool for the user. And that's, I think, a very significant shift in the way we do things. Different objectives, lead to exponentially more DNS queries. And what I mean by that is I had one customer who was talking to me the other day saying, okay, what I want you to do is when the DNS server is getting these kinds of attacks and it's getting all these strange attack packets, what I want you to do is to take those packets and immediately send them over here for analysis. And I said, let me see if I understand that. When you're running out of network bandwidth because you're under a a DDoS attack, you want me to send more network traffic. At any rate, that's part of it. But you have to expect that there's going to be even more of this traffic out there. Much bigger data. One of the things is that people say, there's 400 million Twitter. God, those are big numbers, aren't they? About a lot of transactions, right? Well, for the queries that we handle in our code for our customers, who are typically the big carriers, we're doing about 1 trillion. And all the carriers want to think about, well, what do we want to analyze out of this? What's the behavior we want to detect? What's going on? So that it used to be that it was good enough to answer the question. Now you also want to make sure that you understand why you're answering questions and for whom, and whether or not there's anomalous things going on, whether or not you're supporting a lot of botnets, and all those things. So that we've added this extra layer of implementation. So I think let's talk about what we look for in the near future, and I think the interesting drivers and opportunities for the future. And I'll try and get us more back on schedule. One of the things is, I think, machine to machine. I want the different machines that I own to work together. And there's various proposals for doing that. But, I want the different parts of my house and my different electronic gadgets to work together. Today, that's not the case, right? I have this wonderful iCloud thing that can't synchronize with Microsoft Outlook, right? And you would think that being able to synchronize calendar should be something that you could do, right? And the iCloud support doesn't believe that there's time zones, which I thought was, pretty bizarre, right, for such an international company. But, we've got to figure out how to do those things. Big data. Just doing analytics on DNS traffic and being able to tell people what's going on there. And lots of people do DNS analytics, even if they don't tell you. Being able to do that is one of the challenges we have. Lord help us, there's the clean slate network researchers. These are the people who are doing like the name-based networking, the Xerox PARC, UCLA, et cetera, kind of people. There's about 20 or 30 different research efforts that all say, we just want to get rid of all these addresses, we'll just use names. And it has a bunch of virtues in that they're thinking about, among other things, new paradigms for content distribution network, where you just say, okay, I want to watch Casablanca, I don't care what address it's at. Of course, the people who own those content distribution networks now are typically being gatekeepers and collecting tolls, which is not quite the way that the NSF researchers are doing things. But I think that there's a real growth opportunity in the future for more of this name-based stuff, particularly for organizing resources. And lastly, there's the kind of connected home. I think of this as being different from the machine-to-machine, in that the machine-to-machine is something that's across the internet and, deals with my iPhone here, along with my, Lord help me, I still have a desktop at home, and don't believe in storing all my data in the cloud. Whereas I have sort of a perimeter, and in the connected home, I can have sort of closer cooperation between the devices there. I do have a security perimeter. So I think that, what we ought to think about is, just getting back to some of these base technologies, I certainly think that IPv6 should help me with both the machine-to-machine and the connected home, in the sense that I can just allocate those addresses out there. I expect all of these things to be signing the data that they're sending back and forth, and I would really like to have DNSSEC be part of that. But the trouble is that when I look at all of these security initiatives between RPKI and IPsec and DANE, they all don't seem to be following the same paradigms. We seem to have many different people that are all creating separate security universes for us that, if we think about sort of adventure, right, twisty passages, all different. And I think we need to think about doing a little bit there. Everybody wants to unify around their own paradigm, but until we get some security consistency and sort of aligned game plan, I'm afraid that all of these things are going to be much more difficult than they have to be. So I think naming is everywhere, and I think it's a big direction for the future, not necessarily the DNS. People always ask me what comes after DNS, and I usually say ENS, I guess. You know, I think we're going to continue to evolve the DNS a little bit, but I think some of these ideas about naming and associating the security with the naming are one of the big opportunities for the future. And that's it for me. Thanks.
Okay, great. Thanks very much, Paul.
Hey, it says
All right.
10:08 here. What's going on?
So I'd
Oh,
like
it's coming
to
down.
invite questions from the audience. Go for it.
Thank you. Hello. Jan George. I will, for a split moment, put off my Internet Society hat and talk as a primary co-author of RIPE 554 document and RIPE 501 that, John, you mentioned in your talk. And I would like to put a bit in perspective. There you mentioned 3 profiles and so on. So this is now a big thing in Europe. Everybody is running around with the profiling and so on. And I would just like to clarify that RIPE 554 is a procurement document that helps procurement people to order the right equipment with the lowest common denominator that would work in IPv6 environments, right? USGv6, NIST, IPv6 ready logo are certification profiles. They put a bar much higher. So there are two really different types of usage of these documents. And I think you should clarify that a bit more when you are presenting this stuff. But anyway, thank you for promoting our document.
You bet. That's a good point.
So I wanted to come back to what Paul said about the kind of dismal state of RA and Slack and DHCP. And
Would you like to say who you are?
I'm Owen DeLong. I'm from
Yes,
Hurricane
thank
Electric. We do a little bit of stuff with V6 here and there. You know, and M-bits and O-bits, oh my. Unfortunately, everything Paul said is dead on, and it's even more dismal than what he reports in many cases. But it's actually mostly relatively easy to work around in most cases. You don't necessarily have to run both. If you're trying to get towards V6 only today, you kind of have to run both. If you're trying to make your V6 stuff stand up and actually function in a mixed mode environment, get your name service and stuff from V4 and it's kind of okay. I'd actually like to see an IPv6 name server option in DHCP v4 because that would solve a lot of problems, believe it or not. It's ugly, but it would work. So moving forward, you're going to run into not a lot of DHCP support on the client side. So you're going to have clients that are getting their addresses via Slack. Face up to the fact that you're going to have to do your name service over v4 for now, and things mostly work in a dual stack environment, and that's kind of the best workaround if you're just trying to get stuff working.
Somebody was, Tex Woodworth again, somebody was commenting on the situation in APAC. Before my current project, I went in for 3 months with a small startup in the network hardwaring industry. And I ended up staying 2 years because about the time I walked in the door, they hit the hockey stick curve. And what drove the hockey stick curve in their growth was they made contact with the Asian cell phone providers. And the Asian cell phone providers are very, very aware of the situation on IP addresses. And they put a lot of pressure on A10 to really ramp up the IPv6 stuff, and it got very, very exciting watching this stuff crank up. So I think that in Asia they very much do understand the IP situation, and I started watching a number of other ISPs putting pressure on A10. Okay, we want IPv6 to do this. We want IP6 to do that, and it was very exciting to watch. And the ball is rolling. It may not look like it, but the ball is rolling. And and the vendors are being pressured, and a lot of the vendors are responding. Thanks.
And just as a comment also on the cellular part of it, it's not just in Asia. The numbers are now old, but Lee Howard did some presentations about World IPv6 launch. And yes, we have 1% of the internet doing V6, but as of at least 3 or 4 months ago, so it's been growing, Verizon LTE was over 40%. AT&T had a wireless network that was doing over 25% of their traffic. So yes, there are new technologies that are driving V6 much faster than corporate America.
So I was actually going to go ahead and ask some of that question, but my office is going to say, so why should we go ahead and do IPv6 as a content provider? The answer of 25% of AT&T, some percentage of Verizon, LTE are all IPv6. That's going to hold some weight. What are the impacts of us not providing it right now on those networks? And are there any other major, either U.S., Anglo, India, etc., people that are really, we're not focused on the Chinese market, but other than that, almost global. What am I missing? Who am I going to mess up by not having IPv6, at least on my NetScaler, for example?
If you're a content provider, a large part of the world will soon be operating on IPv6 only devices, and will have to go through one or more translators to get to your IPv4 content. You lose geolocation. You have to have all that aggregated traffic going through these CGNs, LSNs, or whatever. Applications are going to break. Lots of things could potentially break. So that's one of the problems you'll have.
So I actually have some idea of that, but I'm actually curious if, especially from a document or a white paper, if any of these things have been published out. I would be really losing geolocation and all this other stuff is really going to be make my case to my office and to my industry. Actually, we have, for all intents and purposes, the world sees us as one IP. We have a NetScaler, and all my machines are behind it. I know there was a doc that I think Netflix did of their migration turning on IPv6 in public. And all they really had to do was configure their NetScalers or their load balancers to do it, and it was really it. And whatever I do inside my data center doesn't matter. I have 100 machines, but it's one IP for all intents and purposes. So there's a lot of us out there, and the content providers haven't really seen a reason to do it yet. So if there is a doc or a white paper on this percentage of things, this is the bad things that happen if you don't do IPv6, and this is the number of users that are using it in markets that are relevant. If you're focused on China, that's great, but if you're not, that's not helpful. So it'd be really helpful from, just as a general thing to have out there.
Well, some of the presentations, including the numbers that I have from World IPv6 launch, are on the Deploy 360, somewhere around there, and there were about 5 or 6 guys that all presented, and it was Comcast, Time Warner, all of the big providers, Google, and they have their slides available online with some of that data.
When do we think we're going to get updated numbers, especially that the AT&T and Verizon stuff was really, really strong and compelling, so that's just something to note. We're a mobile app provider, so it's really compelling stuff.
Yeah, we're not the ones to answer, but the authors of those slides and studies all have their emails published in the slides, so email them and say, do you have updated data?
This might have been more aimed at the general room, not y'all, just so you know.
Right.
You just brought up the question, to be honest.
Sure, I understand. So you're looking for a small set of documents making the case compellingly for IPv6 that you can talk to your management about to get buy-in? Is that?
Yes,
okay.
From a content provider's point of view.
Got it.
Which is different than consumer or network operators.
I mean, as my fellow panelist said, all of this information is out there. It's scattered all over the place in hundreds of different documents and presentations, right?
Right.
I don't know if there's one that is specifically targeted to your use case, and I agree that would be.
I mean, Deploy 360
very helpful.
It might be an interesting place.
Yeah. Okay. Yeah.
Just a bit ago, I was getting a bunch of tweets from you all saying, okay, where is it documented that the government's going to not renew domains if you're not V6 enabled? It was supposed to have been published a few months ago. It was written by the CIO of the U.S., Stephen Van Roekel, in October, but it was held up for approval of publication in October because there was this thing called an election that was happening in the U.S. and getting anything approved through the White House, they were really worried about spin and how it looked, and so it got sort of lost. I have a copy of that blog article, but it hasn't been published yet. It will be published soon. So I can't give you a link today that says here's where the rules are, but they said we could start discussing it because it was kind of held as a secret for a while. So you may have heard me reference it in a few other forums. So we can start talking about it. It will be published soon.
Mm-hmm. And I'm thinking, so Richard, this is a question for Richard or Dan York. Does ION have any specific documents published already on this topic?
Specific to the last question?
Yeah, or
asked?
similar use cases.
Yeah. So we have a lot of use case documentation that's out there.
Yeah.
I've already taken a middle note, and we're going to be watching the video from this and talking about that after we leave. But just noted from the last presentation, the gentleman said he thinks that he needs a document or a blog post or something pulled together that could create a compelling case for a content provider executive. We're going to put that together and we're going to publish that.
Yeah.
And we're also going to be looking at other things that come up here, and we are going to publish that stuff at Deploy 360.
Great, yeah, that would be very helpful. So I did a day-long tutorial on IPv6 yesterday at this same conference, and some of the questions I got during the break were the hardest problems we're having is trying to get executive buy-in from management to allow us to do something with IPv6. Okay, Dan, you had a quick comment?
I was just going to say exactly what Richard said, but I'll throw in there too. This is, again, if you go to the Deploy 360 website, I'll say it to people who are here, we have a feedback link. And we're very, when we get this kind of comments, this is what we want to hear. I mean, we're building this site out for you all, for everybody in this room, to help take away the pain of getting this out there and help, do this. So if you have these, if you need a document that does this, please go to the site, hit the feedback link, and say, I can't find on your site a white paper that lays out the case clearly for a content provider. Can you help us? And we'll see what we can do.
Okay, great.
Thanks.
So I think we've used up a lot of time. I would like to thank the audience and the panel.